Okay, so I have a question for David. I really enjoyed your presentation. Regarding the tomographic reconstruction, if you have only a small number of vantage points, the problem is underdetermined, I think, right? So what do you use to provide the additional information? Some model that you're assuming or something like that?
Is this working? Yeah, okay, sorry. So no, the problem is underdetermined, but you can still construct some kind of density. And as I showed you, using 3 spacecraft, you don't get much output, but you still get a result. And as you have more spacecraft, that improves. So no, we're not adding anything else. It's just a pure inversion of the images. And so even with just 4, I think we showed 6 and 7 spacecraft, you can get a pretty good reconstruction of this image.
So mathematically speaking, your matrix is invertible even then?
Well, I'm not doing a pure inversion. I'm using an iterative convergence algorithm. I start with a sensible guess of what the background is, so something that falls off with R squared, and I end up with the results that I showed you. So there's nothing else added. That's just an inversion of the data.
Okay, thank you.
Russ Howard from BPL. I want to caution everybody that I think one of the objectives of the PUNCH mission is in fact to determine what the polarization of the F corona is. We do not know what it is really, although I have seen the paper by Christoph Leinert of the Helios mission, who said that the polarization directly above the spacecraft was 20-some%. So I think that is really a big caution that we should be careful about assuming no polarization, which is what we have done when the low corona, the F corona, was in tensor radii. I think that's a good approximation, but not further in. But I enjoyed all your talks, by the way.
Everybody, Rebecca from Muse. David, I have a question about your coronal model. Is this essentially modeled at its own scale based on a real event, or is it informed by smaller scale, lower corona events?
So I don't do the simulations, I do the tomography. So you want to speak to Eric, Ron, or Cooper about that?
Okay, great, I will. And Nathaniel, congratulations on your talk. That was wonderful. Can you tell me a little bit about what's next for you?
Well, I would love to continue looking at this sort of stuff and continue along the path with actual punch data. So that's a sort of short-term step.
Well, I think we can make that happen. Congratulations.
Thank you.
It's a question for Karen. Will you be able to detect or identify coronal CIRs in deep exposure campaigns of the COR2 instruments and also in outside data?
CIRs have been identified in high data, primarily in high 1. I think high 2 things get a little bit more, the images are more degraded and it's harder to see. I don't believe anybody's seen CIR in core 2 data.
Is that because it's too close?
That's always been the assumption that it is too close. I think it was Muir who said that Parker has observed CIRs much further down. So perhaps it is possible if the signal just hasn't been strong enough, maybe both punch having a better signal, maybe we'll see it. But
that's okay. So in high 1 you said it's
Thank
you.
Yeah, Burton Jackson and UCSD. I'm always worried about being able to see the structure of the different features that come out of the heliosphere. So what I did was develop something that would not assume very much, as much as I could. And so we would like we've now got things so we can see a few degrees in latitude, longitude, and in distance over time in a reconstruction of what I do. But one of the 2 assumptions that are being made is that things are pretty smooth usually when you're making a reconstruction, and the fact that you really don't have the acceleration of the solar wind is not really enough for us. It's probably something else. It surely is something else if you consider past flux, because things are clearly more dense and slower at near the Parker Solar Probe and are then accelerating out, at least in the background solar wind. And for CMEs, they can be much higher speed than acceleration. So whatever you do, you should conserve mass flux and worry about the heating or whatever it is that drives the solar and accelerates it.
Great, so by the way, to me, it means that maybe we don't need expensive PhDs to do this. But anyway, no, I had some remark, yeah, good point on the F corona. Yeah, we know that the F corona has some polarization, so yeah, how do you account for that? And also, I didn't see any account of the instrumental nostrilite and noise. When you add all these instrumental observation effects, how does that degrade the predictions of these techniques?
I think in some extent the SOC is looking at that forward model and adding a lot of effects, and then we're using them to do some of these reconstructions. In fact, was that done with Nathaniel's? Maybe Craig can comment.
Thanks. Yeah, I think the CME challenge data set, if I recall, did not have a polarized F corona, but we are accounting for polarization in the SOC that caused us quite a bit of headache a couple of years ago as we set up the polarization part of the pipeline. But I think we're going to hear from Russ that the F corona is also dynamic, and therefore we need to, well, changing, and therefore we need to think carefully. So we may have some surprises ahead of us. That's all.
And actually, if you don't mind me jumping in, we actually had an online question a little while ago, which I'm going to read for Laurent, to Nathaniel, Laurent. When choosing, quote, this is from Olga Panasenko, when choosing to ghost or not to ghost, more radial versus less radial, how will you take into account non-radial CME eruptions?
So the ghost is significantly less radial than the CME trajectory, but also multiple perspectives will also allow to bring that degeneracy.
Okay, go ahead.
From Solar Express Center. I have a question about for the David. It's nice to try this dynamic structure CME. I'm mainly working on the 3D tomograph, spherical cover, is close to the sun. So because you construct for the very structured dynamic CME, and you constructing a very large field view. So I know some technique from you. Do you use a non-uniform grid spectrum for the checking the CME to have a more high resolution? I think because the data is highly undetermined, you must need some regularization.
So yeah, I add a bit of regularization, just gradient terms to make sure the result is smooth, but nothing more than that.
Use a non-uniform grid?
No, so I don't know exactly what you mean by non-uniform. I use a spherically symmetric grid that has it's a constant radial.
Yeah, that's my question, because the field view is very large, so it's
well, I'm using graphs. So we're simulating the LASCO C3 field view, so I think it goes out about 32 solar radii, so I wouldn't say it's huge. But yeah.
Do you, for the tomograph also due to the instrument noise or the...
No, so the simulations don't contain instrument noise or F, right? So
I mean, for the real data, it is very often give the negative big artifact. Do you know how to solve this?
No, so because we've just been doing simulations, we haven't tackled that yet. Although I guess if you're doing it with real data, you'd have to hope that the people who process the data are doing a good job.
Hi, this is Russ Howard again. So I wanted to make a suggestion or that in the early days when we were trying to fit the GCS model to the early stereo data, the CMEs were in the plane of the sky or in the plane of the ecliptic. And so that the various viewpoints were all in that same plane. And so you don't really have much extra information that you can add to that. But if you can get out of the plane as in solar orbiter, we're going to do, that will add a dimension that is really very different, or if the CME is at a higher latitude. So if it's coming off at 45 degrees or 30 degrees, then multiple viewpoints in the ecliptic really do help. So just a
Thank you from Lockheed Martin. Question for Margaret. You showed the results from IBEX on those ENAs. Do you see any solar cycle effect on this? Because we know the high latitude solar wind speed varies with the solar cycle, and then you'll probably see some sort of effect.
Yes, of course. We do see solar cycle effect. It's actually very clear and not like the sun, because it varies from energy to another energy.
The fourth question is, you showed it takes time to develop some effects on the result, like 1 to 2 years, is that right?
That's energy dependent. So, for instance, the higher energy travel much faster. So the lower energies will travel slower. So you would say, but the source distance also makes difference. So you have two factors playing here: the source location of these ENAs and the energy that they have.
So this 1 to 2 years was
1 to 2 years is okay in the nose direction at 1.1 kV or so, maybe a little more.
So that translates to the travel time.
That's the time lag for the solar wind to go, charge exchange, and come back. But that's for the globally distributed fluxes, not for the ribbon structure. Because the ribbon structure is outside the heliopause. That would take an additional 2 more years. Yeah, that's.
Down.
Thank you.
You want to do the other one?
So, to Manchester, University of Michigan, offering question, comment, question about the 3D reconstruction. With the number of lines of sky that you have, you're probably huge number of constraints, so what you have fits, but it's also probably not unique. Is that correct? Yeah.
Go ahead.
Yeah, so that's right. I think a few other people have said that, the problem is under constraint. So there's not a unique solution. The way I'm solving it, as I said, is we start with a sensible guess. We use an iterative algorithm to step towards something that agrees with the observations. And as I showed, we can get something that vaguely resembles a CME using just a few spacecraft. Obviously, that gets better with more spacecraft.
Yeah, more spacecraft is great. I'm not sure if people are familiar with the mission concept of MOST, the multi-observatory. Well, the observatory for solar terrestrial science recently proposed.
Okay, I'm not familiar with that. It sounds interesting.
Yeah, it has spacecraft at L4 and L5, and 2 additional spacecraft ahead and behind that, nearly orthogonal to the Earth, with heliographic observatories.
Okay.
Heliographic, yeah. So there's something proposed, and we're, the white paper submitted, paper proposed, first author of that, Gopal Swami is on that, so we're trying to get support for that mission, and it sounds like it would be really great with PUNCH.
Yeah, sure.
Okay.
All right, I want to finish with, I have personally a comment and a question for the final question for the panel. So polarization is a really powerful tool. I think this is going to change everything when we get PUNCH as to how we use it. And what we heard today, we heard from Nathaniel of how it can do in one dimension. It can follow the front of a CME, and it was really awesome to see that we could distinguish between the front and the back. And we heard from Kurt about how in 2 dimensions, when you're looking on that plane of the CIR, what does that mean and how does that influence? And as I've presented in previous PUNCH meetings, and I also have a launch delayed paper coming out soon, about in 3 dimensions, there's a very interesting relationship directly between the polarization ratio and the radial fall off of the background solar wind. In general, what you've got is, what you care about is the distribution along the line of sight of your density, and then whether it's an infinite long line of sight or what those deltas are that Kurt was talking about. It's actually quite interesting because as you start to go away from the sun, your line of sight becomes asymmetric, and it becomes a very big impact on that integral because you're going from the Earth to infinity, not from minus infinity to infinity. So there's some really interesting things here in diagnostics that we're just starting to learn about. And we're using synthetic data like Elena's, for example, to look at it. So my question for you guys is, and both Kurt and Nathaniel kind of hinted at this, I think. When we're looking at something more like the simulations that we've seen, various things about the PSI and the gamma, the NLIL, when we look at these simulations, it's more complicated. Kurt talked about this, right? That you don't just have a single point of a CME, you don't just have one CIR in your plane of sight. Your background solar wind, you might actually be able to do that with the stuff you subtract out with the SOC to actually do a good analysis. But for the dynamic things, how do we deal with the fact that you have more than one structure along the line of sight? I think Nathaniel gave us some ideas in terms of looking at those error bars and also, looking at them with and without the perfect subtraction. Do you think there's a way to use the time variation to separate out the ambiguities associated with a moving structure, different structures and different time scales in terms of their dynamics? So I want to throw that to the panel and see if they have any comments.
One comment I would have is, I don't know about what you suggested on looking at time variation, but the best way to resolve that ambiguity is to use a different viewpoint. For example, stereo.
Yeah.
So yeah, that's the best you can do.
Absolutely. But with punch, what can we do?
Well, use stereo and punch together.
Yes. Okay. Yeah.
Yeah, definitely.
Good point. Kurt?
I was hoping that time variation, looking at different images at different time steps will help. Just on the assumption that if it's a single structure that at different time steps it's going to move more or less smoothly, and if they are totally different structures, you're going to see jumps around in position in the position that we calculate from the PR ratio. And that would suggest that it's not a single structure. But then how you decide what it is, I think, without having any additional information beyond what David just said, a different perspective, I'm not sure how you would distinguish or be able to distinguish between what's really going on.
But you might be able to do error bars, and I don't know if Nathaniel, you want to comment when you did. What's your insight into the difference between when you did that nice clean subtraction Annie gave you versus the other one?
Sorry.
Well, I mean, if just comment as you wish. Yeah.
So the honest data was mostly single CMEs, so not multiple objects along the line of sight. But I definitely think that the time series observations and seeing how that changes over time definitely could improve distinguishing between those features in front or behind.
Okay. Thank you. Okay, we're just about out of time, but one last one from Bernie.
Like multiple services, that's what I do.
Yeah, refer to your poster on that. A couple quick thoughts though. Related to what Russ said, there's solar cycle effects here. CMEs, there are fewer CMEs at minimum, many CMEs at maximum. The latitude distribution is very different near solar minimum than around the equator. So you have the problem that Russ was talking about. And of course, you go up in the cycle, the CMEs are seen at pretty much all latitudes. And the other 3D aspect is that CMEs often erupt from streamers, and streamers tend to form the base of the interaction regions that we see farther out. So, and blobs and so forth. So CIRs, again, especially more towards maximum, will be very complicated structures. The maximum, I might find it hard to even see them detect or distinguish a CIR from something that's more dynamic.
And if I can just quickly follow up on that, I think in what you were doing, Nathaniel, when you did the version where you subtracted the background, the more complicated one probably implicitly had a CIR because it was a gamma with fast winds streams. So you were probably looking at a CME on top of a CIR versus a CME with no CIR. And so the way your error bar on that kind of decreased is an indication of that kind of ambiguity. Go ahead, Craig.
I was gonna say almost the same thing.
Okay.
Since you said it, let's back out a little bit and point out, we've heard a lot from here and in the past from review panels and even from our proposal evaluation, that polarization is not a lot of things, but it is many things. And we have to remember that we can glean really important information out of it. These simple cases, such as Nathaniel analyzed this summer brilliantly, are great proofs of concept, and they have application directly for some of our brightest objects. The fainter things, it's going to be more challenging, we know that. On the other hand, there is information to be pulled out there, so we just have to be ready for the challenge.
Okay, very, very quick. Yeah.
So, in principle, what we are talking about is observations. Why not use modeling together with it? And that's because modeling allows us to have equatorial cut and a meridional cut, and we see what is actually in the 3D projection. So why don't we use that together?
Absolutely, and that's a beautiful lead into our next section. So we have about 15-minute break now, a little less, 10:20. So please come back for that, and we are going to have a few slide talks, and then we're going to have a panel on models and